So we're going to continue our study of iterative processes with another type of loop called a for loop. I like to think of a for loop really as just a while loop with more features. So often we write a standard loop where we have kind of a starting place. Sometimes it's called like an initialization expression. And we often include some sort of increment decrement feature within the body of our loop as well. And so the for loop just takes advantage of that and pieces it all together. So like a while loop, it's based on a control. It's going to run while it's true. So as long as this middle Boolean condition is true, the loop continues to run. Here's the difference. In a for loop, we actually have a space reserved to create an initialization variable, okay? So sometimes this is referred to as the control variable, the loop control variable. And there's also a space reserved for an increment or a decrement, which means that with every iteration of the loop, this is an instruction for how we would like that control variable to change. Now, in reality, you can put different statements in those places, but what happens is before the loop takes its first iteration, this statement gets read, okay? And at the conclusion of each iteration, this statement gets read. Now, this is all dependent upon the control each step of the way. So if we take a look at these two for loops that I have, one with an increment, one with a decrement, my first loop is going to begin its journey at 5. Since 5 is in fact less than 10, the loop is allowed to take one iteration. And you'll notice that the first time it printed 5, notice that it didn't print 6. Okay, the I++ happens at the conclusion of the first iteration. So that means after we've printed I and a space character, then for the first time we read this increment. At that point, I would become 6. We do not revisit this statement ever again. Okay, it gets read once at the beginning, never again. Since 6 is less than 10, we're allowed to take iteration 2, which would print a 6 in a space. At the conclusion of iteration 2, we would run this statement again, and now we're at 7. And that continued until we did 8, and then we did 9. At the conclusion of the 5th iteration, which is the one that printed 9, when we called the increment again, I would have become 10. At that point, 10 is not less than 10, so we've now stepped out of the loop's control, meaning we've moved past this statement. Since I didn't include braces, we were only in control of this one statement. Okay, I could have braced it as well. This is a very similar process, except I was using a decrement feature, which simply means that my variable is getting smaller throughout. Okay, so I went from 15 to 14, all the way down. Notice that the last number that printed was 9, and 9 was the last number that gave me a true Boolean condition greater than 8. At that point, I would have decremented down to 8, and then we wouldn't have run the loop any more iterations. This first variable here, again, is called the loop control variable. You actually don't need to initialize it in that space. Here I've declared it outside of the loop. One advantage of this we'll learn is then I could actually access that variable again after the loop is over. If you do declare a variable here, that variable is only accessible within that loop. So what that means is if I came down here and I tried to like do something with the I variable, it's going to tell me that it doesn't understand what that variable is. That loop has a limited scope, we say, and it only can be used within the confines of that loop since I declared it within the body of the loop. Okay, so that variable became actually kind of like garbage collected in a sense once that loop was finished. Okay, so down here, by declaring it outside, I could actually access this variable again later if I desired when the loop was completed. Okay, so sometimes we might declare our loop control variables, before the loop begins. In fact, if I wanted to, I could even actually declare this variable and initialize it here. It's kind of weird with a for loop. You can leave this space blank. You do need that semicolon, though, to indicate that you have included the space for that statement. It's just you could actually choose to not initialize anything there. That's not common, okay, but it is permissible. Um, Here we have just kind of an emphasis on the fact that this increment decrement feature does happen at the conclusion of each statement. So if you kind of trace through my loop carefully here, you'll notice that I initialized to 100. And also notice that the first time Z printed, I got 100. And the second time I printed, I got 101. That's because I had called on Z to get one bigger here. So notice that those first two prints did not do anything with this minus 10, right? That minus 10 happens at the conclusion of the first iteration, okay? So the increment statement is executed after the entire loop body is executed. So I had to run all three statements before I took 10 away from Z. And since I incremented Z in the middle, it actually went from 100 to 101, so now it's at 91. So notice that the next two numbers I got to print were 91 and 92, okay? 91 because 101 minus 10, then I added 1, that's how I got 92. After the conclusion of this, printing the 92, then I dropped 10 to take the next iteration, okay? So that led to 82, 83, and so on and so on and so on. I got all the way down to here. Finally, after I printed 29, we could trace the code that far. If you take 10 away, you're at 19. 19 is not greater than 20. That was the first time we saw a false, and then we left the loop's control. So we were stuck in the body of this loop until we got the Z value all the way down to 19. In fact, if you'll notice here, see how I declared Z prior to the loop. That means that I could access Z now. So if we printed Z, it would actually print 19. Sometimes students are surprised by that. They think it might print 29. That was like the last value we saw. But at the conclusion of this statement, we ran that decrement, which dropped it to 19, which caused this to be false. And at that point, you don't like undo anything. Java is never going to go backwards. So once it put 19 in there, it gave that value to Z. That value caused the false. That value caused us to exit the loop. And so if you notice, see that 19 that I have there now, that actually didn't come from within the loop. So maybe I should just put like a little, let's put this on its own line so you can see it a little bit better. But that 19 actually did come from what we call sometimes like the exit value of the loop, okay? And so that's what I was commenting on right here. That's what we refer to as the exit value. All right, and sometimes we, work with for loops. Sometimes we work with while loops. There's no hard set rule that says you have to do this or you have to do that. I'm never gonna like make you choose a certain type of loop to use. It's really always up to you. And in fact, it's real easy to switch from one to the other. The one advantage a while loop might have to a for loop sometimes is that you have a little bit more freedom as to where you might put the increment or decrement, since it doesn't have to happen like at the end every time. But otherwise, there's not a real big difference between the two. So if I wanted to convert this code here into a while loop, it would actually be pretty easy. Okay, so it's not this easy. You can't just take the word for and change it to say while. Okay? It's not quite that easy. Now, since I'm using sum again, I don't want to redeclare it. That really has nothing to do with the loop. So it's not as easy as just saying like change the word for to while, right? In a while loop, I can only have one statement. So this statement here, this initialization expression, I'm going to take that out of the loop and put it in front. Okay, I want that to happen prior to the loop. This thing over here, this A++, remember, when does that happen? It doesn't happen at the start, it happens at the end. So make sure to put that at the bottom of your loop body because you want it to be the last thing that happens. So let's see what this does. I don't think I declared an A anywhere else, so this thing should be valid. All right, and notice that both sums came back as 55. So in both cases, we properly added the values from 1 to 10. I mean, if I put this question on a test and I said, write a loop to add the numbers from 1 to 10, you could do either of these approaches. And there's other ways you could do it too. But So we can use a for loop. We can convert it to a while loop real easily. Just all you pretty much do is just pull the initialization expression out, put it ahead of time, and then pull the step expression out and put it at the bottom of your loop. You want it to be the last thing to happen. And if you want to ever convert a while loop to a for loop, it's almost easier. It's in fact it's almost kind of silly. Let me show you what I mean by that. So if you ever wanted to convert a while loop to a for loop, you could just write the word for and then put a semicolon before and after the control expression. Those statements are optional anyway. I mean, what I just did is kind of dumb, but it's all you really have to do to make it legal, okay? And you can see it actually printed the numbers from 50 to 80, just like the other loop did. Now that's kind of silly, right? I would probably take it a little further. Like I would probably take this initialization expression and move it inside the body of the loop. And I'd probably take this incrementing expression and move it inside the loop structure as well. So it's kind of the reverse of what I'm sorry, I gotta get rid of this one. It's going to count by 2 twice. So it's kind of the opposite of when I turn the while loop into when I turn the for loop into the while loop. So instead of taking the initialization expression out and taking the step expression out, I moved them back in. So I put the initialization expression at the front, and I put the increment decrement expression at the back, and then once again I'm printing the numbers from 50 to 80. When we write loops, we want to be very cautious of what we call an off by 1 error. That's when your loop either stops too soon or goes too far. So we got to be very careful with how many iterations we structure. So let's say that I wanted you to take a string and print the letters of the string individually, 1 letter per line. Computer has 8 letters. So if you wanted to print each of its letters one at a time, then your loop should iterate 8 times. I've set this loop up. It actually is only going to iterate 7 times. So if we're not careful, what I see students do sometimes is, they wouldn't necessarily write 7 there, but they might write like word length -1 because they're fearful of going out of bounds, because they see that this substring is going to go to x plus 1. They think, oh, I better stop shy of the length because if not, I might go out of bounds. This loop wouldn't go out of bounds, and it would actually miss the R. This loop's going to function 1 too few times. And so what I mean by that is if you see right here, it only printed the first 7 letters of computer. It didn't reach the R. So what should I have done? Well, I've got a few choices. Okay, I could either take off the -1. That would print all 8 letters of computer. I could have left the -1 there and changed this to be a less than or equal to. Sometimes when you see me write loops that interact with strings, what you'll notice that I like to do is I like to look at, especially if I'm substringing, I like to take that bigger quantity, okay? So in this case, x plus 1. And remember, the rule for substring is that you can always put the length into the string. So I figure as long as this bigger quantity doesn't exceed the value of the length, then it should take me right up to the end without going out of bounds. So sometimes you might see me write controls like this when I interact with strings and substrings. And you can see how I got all 8 letters of computer. But in reality, I just showed you like 3 or 4 different ways to do it that all works. So you just kind of pick whatever works for you. And it's even worse if your loop goes too far. So if we set up a loop that goes 1 too far, it's going to carry out of bounds. Okay, now typically, I don't think, we probably wouldn't put the number 9 there, but what sometimes students might do is they might say x is less than or equal to word.length. And by including that or equals to, that's actually going to give me 9 iterations because of how I started at 0. It's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. I just actually listed 9 numbers, counting the 0 and the 8. And there's not 9 letters. That 9th iteration went out of bounds. So we got to be careful. We don't ever want to create an out of bounds error.